I'm Ravi. I'm a mechanical engineer in profession and I'm actually interested in teaching physics. So I'm starting a new series of videos to discuss some important questions which can come across in your examinations. So these questions will be basically for the advanced level examination. We will go into deep of some questions one by one. So I really find this series of videos will be very helpful to you. So let's begin our series. Let's take a look at our first question. So the first question says that a 600-meter wide river flows directly south at 4 meters per second. So we will draw the diagram like this. So there's a river. The width of the river is given as 600 meters. Flows directly south at 4 meters per second. So this is flowing directly south with a velocity of 4 meters per second. A motorboat travels at 5 meters per second in still water. There's a small motorboat and it can travel at a speed of 5 meters per second, but this is in still water, right? So this is the special data, right? We will write that data later. Still water and points in such a direction so that it will travel directly east relative to the land. So that means an observer. So if you consider an observer on the ground, land, he observes the path of this boat is directly east. So it is like this. So this person is observing from the land and it observes that this boat is moving directly to the east. No, not to any other direction inclined to the east direction. It is going directly to the east. Okay. And the question is asking what is the time taken for the boat to cross this river. So it seems a very simple question. Yes, of course, it's a very simple question if you know the theories well. So how do you find? The distance is given. So you have to find the time taken. So it is very easy to find the time taken. You can apply S equals UT. You can apply half AT square, but here we do not have any data regarding accelerations. Therefore, you can directly use S equals UT. So if you apply S equals UT, you can easily find the time by dividing the distance by the velocity, which is U. So if you put 600 meters as the distance, then you have to find the velocity or the speed to that direction. That means the velocity of the boat in the east direction. So it is not given actually, right? So what we have given is velocity of the boat with respect to river. Still water means the river is not moving. So for simplicity, I will put B for boat and R for river, and I will put E for the land or the earth. So the velocity of boat with respect to the river will be 5 meters per second, but the direction is not given. And the velocity of river with respect to earth is given, that is 4 meters per second from here to here. And velocity of boat with respect to earth is given, not the magnitude but the direction. So you have three vectors given. So these three vectors, the first vector, it has only given the magnitude. If you consider the second vector, we have given both the direction and the magnitude. And in third vector, we have only given the direction. So we have to combine these three vectors. So if there are three vectors, you can easily construct a vector triangle, right? So we will write down expression corresponding to these three vectors. So the vector expression will be like this. So the velocity of the boat with respect to earth, we can write it as velocity of boat with respect to river plus velocity of river with respect to earth. So this is from the vector addition. So BE in this direction, we do not know the magnitude. We only draw the direction. BR means 5 meters per second. We do not know the direction, but we know the magnitude. just write it down, plus RE, that is 4 meters per second in downwards on the south direction. Okay, now this part has become the resultant. The summation of these two vectors will give this vector. So for easy notation, we can label this one as PQ. And if this is P and this is Q, and if you consider any triangle like this, so if you consider three sides of a triangle P, Q, R, if P and Q represent two vectors, the resultant vector is represented by the PR vector. If you represent two vectors by two sides of a triangle PQ and QR connected end to end, the resultant will be given by the PR vector. That is very simple. So you can use this technique here. So if you put this one as PQ, then definitely this one should be PR, because this is the resultant here. According to the equation, this is the resultant. So if this is PR, then this should be definitely QR. Now we can construct the vector triangle. Easily you can construct. How? See. So PQ is downwards. You can see here. PQ is downwards. P here. Q here. And PR is horizontal or to the east. PR. And this is 4 meters per second, and we do not know the magnitude. We put U here. And this is U, and this will become 5. QR is 5. Now you have a right angle triangle. You know that from the Pythagoras theorem. If this is 5, this is 4, then definitely this should be 3. Right? Because this side is equal to 5 square minus 4 square. So if I write it, U is equal to 5 square minus 4 square root. This is the hypotenuse. So you can easily find this one as 3 meters per second. Hope it is very clear. Now what you have to do is, now we have found U, then you can easily find the time taken. So the time taken will be 600 divided by 3, that will be 200 seconds. So this is a very simple question. So what we have to learn from here is, we must write down the data in the vector format like this. Then we have to construct the vector equation corresponding to this question. Then we have to draw a vector triangle and find the unknown vector. Direction or the magnitude you can find by constructing a vector triangle. Then you can apply that data to find your final answer. Okay, so this is a very simple question, and I think hope this is very clear to you.